Hello, welcome. This question, merge intervals, is a medium level difficulty question. It provides you an array of intervals where there are two elements in each interval, star and n. Importantly, star is always less than or equal to n. You are asked to merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So how can you do that? A brute force solution is provided here. Please feel free to pause the video to read the information in some detail. Basically, there are two steps. Step 1. From the first interval, merge with the remaining intervals, one by one, iteratively, if overlapping. So the first interval compared to the remaining interval, one by one, one by one, one by one. If they overlapped, then merge back to the first interval, merge back to the first interval, until no further overlap. And we repeat this process to the second interval, compared to the remaining, and merge back to the starting interval, merge back to the starting interval. So this process, as you can see here, has a two while loop, I and j, and it has a time complexity O n squared, at least. After running this, we achieve a 84 millisecond runtime, faster than 40% of other submission. Pretty good, but how can we improve the time complexity here? There are two tips I would like to provide here. First, when the question asks about merging elements in a list, which has many combinations, we can simplify the problem by sorting the elements first, and then we can traverse down the list to achieve a linear time complexity. Second, instead of handling two elements, we can simplify the problem by sorting the first elements first, so that we can focus on the second elements. After we sort the intervals by the first element, then to decide whether two intervals can be merged, we only need to examine where the second elements from the first interval, which is the A here or the 10, falls into the range of the two elements in the second interval, which is B here or 2, 3, this range. And there are only three conditions here. First, the element falls before the range, which means no merging is necessary. Second, the element falls inside the range, which means merging. 3. The element falls after the range. It also means merging. Before we write the code, I would like to introduce a lambda function in Python, which is a single-line anonymous function that is very useful when it used inside another function, for example, filter, map, and sort. And in this question, we'll use the lambda function with the sort function to sort the item by the first element. With all the background knowledge introduced, we are now ready to write the code. So first of all, we'll sort the interval list using the sort method by the first element. And the trick to do it in Python is to use the lambda function, as in here. Okay? And after it's sorted, we want to create a result list, and let's use the first interval here as the first this element. Okay, and we want to iterate through the remaining intervals. Now the question is, since the first element is already sorted, we only need to focus on the second element. So our question is the second element, how is compared to the next interval's first element. Okay, if it's less than, and that's our condition 1, and no merging. So no merging necessary, then we will simply append the interval to our result list. Else, if this second element is larger than the second element of the follow-up interval, that's our condition 3, and there's a merging here. It falls after the range, and in this case, we'll merge in this case we don't need to do anything. We will continue, but without because our interval here is already including the far interval, so we don't need to do anything. And finally, it means that it falls within that range. And in this case, the second element will be modified to the second element of the follow-up interval. So these are condition 2, and we will do a merging here. And finally, we will return the results list, and let's test this. Okay, pending, and done. And 64 milliseconds, pretty good. So the time complexity here appeared to be an improvement over the brute force solution. And now let's analyze for complexity in this solution. So the time complexity, well, first of all, the sorting method has a time complexity O n log n, and the iteration here just one time linear, so O n. So it's dominated by the sorting method primarily. So our time complexity is O log n, n log n, and for the space complexity, so the sorting method has a space complexity O log n to O n, and our result here space complexity O n. So it's between these two, log n. Since our space complexity is O(n), so it's also dominated by our result for sure. So we have O(n) as our space complexity. And that's it. Hope you find this video to be useful. Subscribe if you like, and see you next time.